And we're in, this is 7.2. We're starting into 7.2. So we're talking about surface area and volume of prisms. Now let's remember, before we start talking about our surface area and volume, remember what we need to have a prism. What makes a shape a prism? So what do we have to have? What's important about prisms? Two bases. They're three-dimensional and they have two bases. So they're 3D, they're a solid shape. And they have to have two bases. What is important about the bases of prisms? They have to be congruent. And what else? One other thing that's important. They're congruent and, anybody remember? If we think about our shape that we did our opener with, if we look at the two bases, they're congruent and parallel. There we go. They have to be congruent, parallel, and just so we know for sure, they're polygons. If our bases are circles or some other curved shape, then we don't have a prism, we have a different kind of shape. So we have to have two bases, they have to be congruent, parallel, and they have to be polygons. So let me draw, before we talk about the formulas that we're going to use today, we need to know one other part of a prism. So let's draw a prism here. I'll make it a triangular prism. Whoops. So here are our bases. And we'll connect the edges here. So there's our prism. The other part that we need to know about is the altitude. So I'm going to draw a segment in here. I'll do it in red. Let me make it so it's a little easier to see. There we go. And this red line, this red segment, makes a 90-degree angle with each base. What did I do there? Somehow I got an extra line there. There we go. So there's our segment that we're interested in, and this is called, the segment is called the altitude. And it is how we find the height. So it's like we did with triangles or parallelograms or trapezoids. The altitude is the name of the segment. The height is its length. Often we use the name, both words to mean the same thing. Altitude and height, we kind of use them interchangeably. So just know that to find the altitude, the height of our prism, it's a segment that connects the two bases at 90-degree angles. So our altitude is the segment at a 90-degree angle. All right, here we go. So someone was just upset about something, but it's okay. Yeah, it was one of my former students, and she was talking about another one of my students. But they were
They start scrapping?
no,
Yeah.
something like that anyway.
Please all go give her a hug. All of us.
She said she was okay. I offered. I said.
Never okay, Mr. Beamer.
I said, do you need anything? Do you need my 5th period class to give you a hug? And she said no.
That is so bad. You should drop that and give her some chocolate.
I made her laugh. That was a
You made her
good thing.
laugh?
Yes.
No, you're not very funny. Hey, you got one joke up like that hurts.
All right. So Nova asked if it's standing up or if it's laying down. That's kind of the weird thing about drawing 3D shapes on a flat surface is they end up looking like both. And then if you look at it one way, then suddenly it'll like and it'll be the other way, and it's kind of weird.
So it is both?
It can be both, yeah. It can be either. So Nova asked if the prism was standing up this way, or if it was laying down this way. And you can kind of see it being both ways. So I see it like triangle could be the top and the bottom.
The back side is like the base of it.
Right, the triangle could be the top or the bottom, or this could be like the top edge, like a tent.
I know.
Yeah, that's what it said. It looks like that.
Yeah.
Let's do camping. Yeah, wait, what's inside the tent?
How can it be on its altitude?
Isn't the altitude just like one of the engines?
So that's a good question. So on this particular prism, the altitude, we could find the altitude by one of the edges because this is a right prism. If our prism were oblique, if it were slanted, then like a triangle, we can have the altitude outside. So that's why we need to worry about it. And I just want to draw it in there because we're going to be using the altitude for pretty much every shape we talk about.
Is that
Yes.
going from like this triangle to that triangle?
Yes.
Okay.
So it's touching the triangle down here, and it's touching the triangle up here. It could be a tent, or it could be like a standing up. All right.
Wait, it looks like a pizza?
A slice of pizza.
2 slices of pizza.
So really like a thick square one. Yeah, more like a slice of cake.
I didn't say that.
All right. Okay, we've gone way off on a side trip here.
We should have a pizza party. That'd be awesome. Is there a pizza day so you can do fractions?
We could bring pizza on Pie Day.
Sure.
Yeah.
Actually, no, I like pie a lot. You even have this way better than pie.
All right. So now that we know what the height is, how to find the height, now we can talk about our formula. So our surface area.
It's a Wednesday, Mr. Beamer.
And I think it's isn't it one of the CSAP days? I think it's on a CSAP day also.
No, wait, there's 2
Pi Day?
What?
Are you gonna miss Pi Day? Sorry. I just told you.
What do we do tomorrow?
My birthday's March 11th. We put them together. And bring cake.
You could bring a round cake. That's fine. All right. So. All right. Let's focus. Let's focus. So we're going to talk about our formula for the surface area of a right prism. Surface area of a right prism. Not too long. Not too long. We have a couple of formulas and a couple of examples, so not too long. So for a right prism, we need our parts of our formula. For our formulas, our capital B is going to be the area of a base. H equals the height, and P equals the perimeter of a base also. So our surface area formula, S equals HP plus 2B. And this is our formula for the surface area of any right prism. Now the formula that we talked about before, the one we used on the opener, only works for right rectangular prisms. This formula works for any prism, including right rectangular prisms. So the one we talked about before was kind of a special case. This one will work for anything, as long as it's a right prism. Now this capital B, this area of the base, this is why what we did last chapter, finding area of all those different kinds of shapes, is important, because we're going to have prisms that have triangles as bases, trapezoids as bases, hexagons as bases, parallelograms as bases. So we need to be able to find the area of those different shapes to figure out the surface area of our prism. So our area formulas from last chapter are still really important for what we're doing. And the other thing that's hard, that makes this chapter a little bit challenging, is we're going to be talking about, we're going to use the same word for a lot of different things. We have the area of the base. If our base is a triangle, the area of a triangle is 1/2 base times height of the triangle. So we're talking about the base and the height of the shape that makes up the base. And then we have the base of the prism. We have the height of the prism. So we're using one word to talk about a lot of different things. So it can get a little confusing. So let's look at an example of using our surface area formula. When we use our surface area formula, we need to find three things. We need to find area of a base. We need to find the height. And we need to find the perimeter of the base. We need all three of those things to use our formula. If you find all three of these things, then you can use your formula. Sometimes they'll give them to you in the problem. Sometimes you have to use other things that you already know to find these things. So let's look at an example. Is everybody good with the formula? Okay. So our example, we have a regular hexagonal prism. Sure. Good? Okay. We have a regular hexagonal prism. Our height is 12 centimeters. Our apothem equals 10 times the square root of 3 centimeters. And the base side length equals 20 centimeters. And we want to find the surface area. So if we were to draw a quick picture of this, of what we're talking about here, do I have a hexagon here? I do. There we go. So here's our prism. here's the shape that we're talking about. So our prism is our base. We have two congruent parallel bases. The side of this base is 20 centimeters, and the height is 12 centimeters, so it's not drawn to scale. And our apothem of our hexagon from the center to the center of a side is 10 square root 3. So we need three things. We need the area of a base. How do we find the area of our base? We remember? For a hexagon? 1/2 the apothem times the perimeter. That's our formula for the area of our base. So we have a formula for the surface area of the prism, and we have another formula for the area of the base. So we have to keep track of a lot of formulas. Our apothem, we know, equals 10 square root 3. And our units are centimeters. What's the perimeter of the base? That's the second piece of information we need for our formula. So what's going to be the perimeter of our base? 120, and how'd you get that? Add up all the sides, so we have 6 sides, and each one is 60. So P is 6 times 20, or 120 centimeters. So now we have two pieces. We can calculate our area. We'll calculate our area, and we know that our height is 12 centimeters. So our third piece is h equals 12 centimeters. So let's find the area of our base from our information. So B, the area of our base, is 1/2 the apothem, 10 times the square root of 3, times the perimeter of the base, is 120. If I calculate that all out, that comes out to be about 1039.23 centimeters squared. So there's one part of our formula, and we have the height, we have the perimeter of the base, so now we can find our surface area. Surface area equals the height times the perimeter, 12 times 120, and we're talking about the perimeter of the base, plus 2 times the area of the base, 1039.23. And if we calculate that all out, we get that it's 3518.46 centimeters squared. So to find the surface area of this prism, we had to find the area of a hexagon. We had to find the perimeter of a hexagon. We also needed to know the height. So depending on the shape of the base and depending on the information that we give us, we might have to do a little work to use our formula. Questions on this example? All right, let's talk about our volume formula for a prism. So for our surface area formula only works for a right prism. Our volume formula works for any prism, and I'll talk about that in just a second. So we need capital B again. Capital B is the area of the base. You guys with us? And H equals the height. So B is the area of the base, h equals our height. The volume is the area of the base times the height. And that's going to be units cubed. Now, we talked just the other day about the volume of a rectangular prism. So we had something like this, like we did for our opener. So there's our prism. And we said that the volume of this shape was L times W times H. Well, if we think of this rectangle as the base of our prism, L times W is the area of the base. L times W is the area of one of the bases. So this formula then tells us that the volume is L times W is capital B, base times the height. So this formula that we talked about before is exactly the same as this formula. This formula only works for rectangular prisms, right rectangular prisms. This formula works for any prism. And let's talk real quick about why it would work for any prism. So here's our rectangular prism like we talked about before. And the volume of this prism is four books. The volume is 4 books. If I make it into an oblique prism, so I slant it like so, is the volume any different? Did I change the number of books that make up my prism? No. So the volume is still 4 books. So the volume of this prism is the area of the base times the height, and the volume of this prism is still the area of the base times the height. So that's why this formula works for any prism. They call that idea of slanting your prism, that's called Cavalieri's principle. He's the one that figured it out. Questions on the volume formula? By the end of this unit, we're going to have a bunch of formulas for our different shapes. We're going to talk about a lot of different shapes this unit. So we're going to need to keep these straight. So let's look at an example of using the volume formula, and then we'll talk about where the surface area formula comes from, and then we'll be done. We'll do some other things. So we have a right triangular prism. And this is, the height is 10 centimeters. And this is the base. So that's the base of my prism. And this is 2.5 centimeters. This is 3 centimeters. And this is 5 centimeters. We want the volume. So for our volume, we need 2 things. We need the area of the base, and we need the height. So for the first one, our area of our base, how do we find the area of the base of our prism? So how are we going to find the area of the base of our prism? What do we need to do? Base times height times 1/2. So what's the base and the height of our base? 3 and 2.5. So the area of the base, now notice already we're talking about the base and the height of the base, and we have the base and the height of our prism. So it's easy to get confused about what we're talking about. So the base and the height of our base is 3 centimeters and 2.5 centimeters. So our area of our base is going to be 3 times 2.5 divided by 2. And if I calculate that out, I get 3.75 centimeters squared. We know our height. It gives us the height of our prism is 10 centimeters. So our volume is 3.75 times 10. And I get 37.5 centimeters cubed. Questions on that formula? All right, let's talk real quick about our surface area formula, and then we'll be done with our notes. And part of this, you guys have done some of this before. So let me draw a prism like the first one we used. So we have a triangle here and a triangle here, and we're going to say this is a right prism, even though it might not look like it. So our tent shape again, right? And we're going to say that this side is 4, this side is 4, this side is 4 square root 2, and this length is 7. So our height is 7. The sides of our triangle are 4, 4, and 4 square root 2. If we open this, if we cut this open and lay it out flat, we get a shape that looks like this. Make that look a little better. So if we're cutting this all open and laying it out flat, what do we call it when we take a shape like this and cut it open and lay it out flat? This is our net. That's exactly right. This is a net for our prism. So if a problem asks you to make a net for a shape, it's just asking you to draw what it looks like all laid out flat. Let's label the sides, the lengths of the net based on our drawing here. Our triangle is 4, 4, this is 4 square root 2. This has to be 4 to match up here. This has to be 4 to match up there. And this side is 7. And it would be the same on the bottom here. Now, our formula for our surface area, we said the surface area is HP plus 2B. To find the surface area of the prism from our net, what we have to do is find the area of all the flat pieces and add them all together. Well, the area of this triangle is the area of a base. The area of that triangle is the area of a base. And I've laid this rectangle out, so now I have one big rectangle instead of three smaller ones. The height of this rectangle, one side of this rectangle is 7, the other side is 4 plus 4 square root of 2 plus 4. Well, 4 plus 4 plus 4 square root of 2 is the perimeter of the base. 4 plus 4 and 4 square root of 2 on this side. So the area of the big rectangle, I'm going to do a highlighter around that one. The area of this highlighted rectangle is the height times the perimeter. That's the area of that rectangle. Here's the height of my prism, and this is the perimeter of the base. So my surface area here on this net is the area of this rectangle plus the area of 2 of the triangles, 2 of the bases. So that's why that formula looks the way it does. If we make a net and add up all the areas of all the pieces, that's how we get this formula. So I wanted to show you 2 things with this. 1, to remind you what a net was, and 2, just to give you an idea of why the formula looks the way it does. Any questions? All right.